Okay, so ladies and gentlemen, you may have seen a slide like this in a previous conference, and if you have not, I assure you that that day is coming. And if we liken the knowledge for the search for knowledge to an archaeological dig, then this slide shows you how much earth was moved rather than what was found. It mistakes dirt for treasure. It's short, thankfully. It's complete. I really hope there isn't more. But it's in its fervor to show how much was done. It lacks clarity, and it asks too much of you, and it leaves you in confusion. So I think let's try again. Suppose you want to understand tumor evolution. So normal cells accumulate some somatic genetic alterations, and they grow. There's a treatment that kills some of them, but others survive and they form relapses. Meanwhile, other cells travel to distant tissues and form metastases. So that's kind of tumor evolution in 20 seconds. It's certainly not complete. There's a lot more to it, but it's short and it's simple. And as Einstein said, we should make things as simple as possible, but not simpler than that. And so the hope is that a slide like this would leave you curious and inspired rather than confused. So how important is accuracy? Well, this sentence is very accurate. It's extremely precise. Try to figure out what it means. It's short. So I haven't really broken any of the rules of communication. But you don't really stand a chance to understand it. But yet you know there's something wrong with the sentence rather than you. So if you realize that buffalo is also not just an animal and a place, but also a verb meaning to bully, then you can see what this means. It's buffalo, 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 buffalo. That makes sense. Now, you're laughing because you wouldn't do this. You wouldn't do this to language, and so don't do it to your data presentation. There's this sense that we need more data to clear up misunderstandings. Well, here's a poll finding, which I find rather worrying. And I assure you that 100% of these people do not need more information, as the information deficit model would have you believe. More data isn't always the right thing. So here's a buffalo chart. What is this? This is the US, one instance of the US health plan. You can see that the distance between healthcare providers, if you can find them, and patients, that is consumers, if you can find them, is mired with boxes. And this is why nothing ever gets done. Now, there's a defense mechanism. A defense department is also involved. So what do we stand to lose when we do this? We stand to mistake junk science for real science. Astrology, gene evolution, it looks the same to me. And so if we continue to present without clarity, we will wallow in ambiguity that drives this kind of junk. So how do we approach things? Well, you can think about presentation the way you think about language. You don't take shortcuts at the expense of clarity. You use terms that are definite and concise. You don't use meta-language, concepts about concepts like framework and structure and methodology. These are tedious, they're ornate, and they're actually nauseating. So we did this column in Nature Methods, which is a part of a visualization series about storytelling. That's a fairly banal word. And we thought we'd say some uncontroversial things, distinguish detail from minutia, don't give in to the desire to show all your data, provide proof, justify your statements, but stick to the plot. Well, we got some criticism. It was confused that when we meant story, they thought we meant fiction. And so, of course, the clouds darkened, and distant thunder was heard because we were embellishing and concealing information. We would just take truths and sweep them away. Presumably, the science lab has a large carpet. But the thing is, we don't need to do this. We can show data and hide truths that are embarrassing in plain sight. Here's something. You know what this is called, but you don't know what this is showing. There may be embarrassing things that I don't want you to understand, but because you can't understand the whole thing, there's no need for me to hide anything. So there's this emerging hysteria now that for big data, we need big thinking. Small thinking of yesterday isn't enough, no. We need to expand our minds, and I assure you that the students in this photo are in fact having big thoughts. I know this because the caption said so. The thing is, if we look in history, there is some precedent and proof of big thoughts as far as 2,000 years ago. Lots of people uttered big thoughts. We've been thinking as big as possible for the longest time. We've tried to figure out how to distinguish bad big thoughts from good big thoughts and act on them. it's a revolution. It's going to change the way you live, work, and think. And in fact, you're going to have to send your children to a new school where they're teaching with big data because the way they're teaching it now is inappropriate. The question is this really the first time that we've been faced with more information than we know what to do with? And I would say that the answer is no. These guys are faced with more information than they know what to do with. They're literally being ravaged by the unknown. Their data is not only big, but it's scary. They have no clue what's going on. So clearly, they're having as big a problem as they can manage, in fact, bigger than they can manage. And this is the case for us. The definition of scientific endeavor is to be working on the margins of confusion. We are always confused. Kepler, you could say, Kepler would say, if he loved jargon, he had big data, because he had to do this calculation about the orbit of Mars 70 times, and it took him 5 years. Now, think about the last time you had to sit at a desk for 5 years doing a calculation. You didn't. So what am I trying to say? Is that, yes, we have more data. Yes, it's more complicated. Yes, we're accumulating it faster, but it's clear that we can no longer report in proportion to how much we have uncovered. Here's an example. The original Watson and Crick paper had one figure. The genome paper had over 50, and the 1000 Genome Project had a 1/10 of that. So next time you present, instead of just showing data, try to figure out what you found, whether it's important, how to place it simply into the mind of the audience, place it in the center of your slide, and be done. Thank you.